look at another way to solve quadratic equations. We talked about in 12.1, one way to solve a quadratic equation is by factoring, and this method is solving quadratic equations by taking roots. And you can use this method if your b value is equal to 0, which means that you have an x squared term and you have a constant, but you don't have a plain x term. So it's going to look something in this form, x squared minus c equals 0. You also might have x squared is equal to c. What you're going to do is you'll isolate the squared term and then take the square root of each side of the equation. Let's say we have x squared minus 64 is equal to 0. So that means that x squared is equal to 64. And then when we solve, we'll square root both sides. And remember, when we learned how to solve square root equations, if you're taking a square root of a variable, your solution is going to be the positive and negative. So that means that we'll have positive square root of 64 and negative square root of 64. So you'll have plus or minus 8 for your final answer for x. So the square root property is like this. If the n is greater or equal to 0 and x squared is equal to n, then x is going to equal to plus or minus n. If n is greater than 0, then x is going to have two real solutions, and if n is equal to 0, then x is going to have one real solution. Okay, and then if your n is less than 0 and x squared is equal to n, then x is going to have no real solutions, because when you take the square root of a negative number, you get no real solutions. So let's say we want to solve 2x squared minus 24. So first we will try to isolate the x squared. So we'll add 24 to both sides. Then we'll divide both sides by 2. And then we'll square root both sides. So we'll get plus or minus the square root of 12. And then in the last chapter, we learned how to simplify radicals. So we know that the square root of 12 simplifies to 4 times 3, and the square root of 4 is 2. So our final answer is plus or minus 2 square roots of 3. X squared plus 2 equals 36. So notice that the x plus 2 is inside the square. So this is one thing that's being squared. So we can go ahead and square root both sides. And the square root of 36 is plus or minus 6. So we have x plus 2 is equal to plus or minus 6. So when we solve for x, we're going to subtract 2. So now we have the subtracting 2, or minus 2, plus or minus 6, which equals x, which means we have two solutions. We can either do negative 2 plus 6, which gives us 4, or we can do negative 2 minus 6, which gives us negative 8. So we end up with two solutions. However, we need to make sure that we check each solution in the original equation. So we have 4. 4 plus 2 is 6, and 6 squared is 36. If we have negative 8 plus 2 is negative 6, and negative 6 squared is also 36. So they both check, which means that they are both solutions. Okay, so whenever we have a quadratic in the form of ax squared minus c equals 0, these are our steps. First, we isolate the squared expression. We apply the square root property. We simplify the radical and solve each equation. Here's another example. We have x minus 5 squared equals 21. So we'll square root both sides, and we get plus or minus the square root of 21. And the square root of 21 is prime, so it's not going to simplify after that. We are going to add 5. So our solution becomes 5 plus the square root of 21, or 5 minus the square root of 21. If we wanted to go ahead and approximate that using a calculator, we would get 5 plus 4.58, which is what the square root of 21 is, or 5 minus 4.58. So usually we don't want to approximate. However, if we needed to because we were looking at a word problem, or we needed something a little bit more specific because we're looking at it in terms of feet or inches or some sort of problem that we're solving, then we would go ahead and say that our solution is 5 plus 4.58, which would be the 9.58, or 5 minus 4.58, which is 0.42. And so we could say that our solution set is 0.42 and 9.58. So notice that when I write a solution set, I use my set brackets, and then I also write my solutions in order from least to greatest. Okay, let's say we have 7x squared plus 6 equals 2x squared plus 8. And you might think about how this doesn't look like the form ax squared minus c equals 0. However, I also don't have a bx term. So remember, that's the term where you have just x to the first power. So since it doesn't exist, that means that I can manipulate this equation to where it is an ax squared minus c equals 0. So the first thing I'm going to do is I'm going to get both x squared terms to the same side. So I'll subtract 2x squared from both sides, and I'll end up with 5x squared plus 6 equals 8. Then I can subtract 6 from both sides, and I get 5x squared equals 2. Then I'll divide both sides by 5, and I get x squared equals 2 over 5. Notice how I'm going to go ahead and leave that as a fraction, and then I'll square root both sides, and I get plus or minus the square root of 2 over 5. So we learned in the last chapter that we don't like to have a radical in the quotient. When we're going to apply the quotient property, and we'll have plus or minus the square root of 2 over the square root of 5. And then we're going to rationalize the denominator by multiplying the numerator and the denominator by the square root of 5. So we get plus or minus the square root of 10 over 5. So when we solve a quadratic equation such as x squared plus 7 equals 0, we end up with getting x is equal to plus or minus the square root of negative 7. So the square root of negative 7 is not a real number. When we write our solution, we're just going to go ahead and leave the negative number under the radical and just state that there are no real solutions. Okay, so one way that we're going to use this in real life is if we have a free fall equation. And so that's when we have an object that is at a certain height, and the height of that dropped object can be modeled by the function h of t equals negative 16t squared plus hi. T is going to be the time in seconds, and hi is the initial height in feet. So the amount of feet that it drops, and this is the function for that. Let's say that we have this function, and we want to know at what time does the ball hit the ground, or the object hit the ground. So if the ball is hitting the ground, that means the height of the object is now 0. Okay, so what we can do is we can solve for t to figure out at what time does the ball hit the ground, or what time is the height 0 feet. So we'll go ahead and subtract. Actually, if you see that this is a negative 16t squared, the one simple way to do this is to go ahead and add 16t squared to both sides, and now you're no longer dealing with negative numbers. So now we have 16t squared equals 150. We can divide both sides by 16. So we have 150 over 16, and we'll square root both sides. So we get plus or minus the square root of 150 over 16, which is 5 square roots of 6 over 4 after being simplified, which is approximately 3.06. So again, this is one of those problems where if you say the time was 5 square roots of 6 over 4 seconds, that doesn't make a lot of sense to the average person. So you would rather say 3.06 seconds. And because of that, you also wouldn't say it's negative 3.06 seconds. Time can't be negative. So you would say that the only reasonable answer would be positive 3.06 seconds. And so you can say that's how long it took for the object to hit the ground.